Okay, so we're at the stage where, the 53rd problem, by the way, and this is a typical, I'm going to say, in introductory calculus, this is a typical thing that a teacher presents at the board, and they want to know, what the definition of the, using definition, what the derivative is. And typically they do it for sine, they do it for cosine, and then they use those two and rules to derive the other derivatives. But you should know at this point that if f of x is sine of x, you should know at this point f prime of x is cosine of x. And you should know if f of x is the cosine of x, that f prime of x is minus sine of x. And from those two, you can derive the derivative of all trigonometric functions. I'm going to erase this, though. And I want to point out that, certainly at the end of this thing, they're listing what I do know. I know the derivative of the sine function's cosine. So how would you do that? I mean, what I would recommend you do is write the definition down now. So I'm going to write down d dx of the sine function. Again, I know it's cosine x, but the definition of derivative is going to be limit, let's see, h goes to 0, and then you get sine x plus h minus sine of x over h. All right, so that's an important place to start with. And then the question is, what do you do with that? There's a lot of work to be done at this point. I'll write this over your limit. H goes to 0. And what do you get? Well, you need to know your trig. That's going to be sine x cosine of h plus sine of h cosine of x. What I do over there, I expanded this using the sum formula, and then minus sine x over h. What do you do with that? I mean, there's no cancellations I can say. Well, what I'm going to do is I'm going to kind of manipulate it a little bit, and I'm looking for something. I'll tell you what I'm looking for. I'm looking for the limit, and this is something you did when you studied the squeeze theorem. I'm looking for the limit as theta. Yes, I'm using theta for a reason. I want to confuse with the problem. Goes to 0 of sine theta. That's what you did by the squeeze theorem. And that equals a number 1, right? Another limit from this one over here that you should know about, the limit, it comes from this one over here. Theta goes to 0 of cosine of h. I'm sorry, not h. I got h in my mind. Let me erase that. Cosine of theta minus 1 over h is equal to 0. All right? So there's two limits I should probably know before entering this, and I'm going to look for those. And I'm kind of seeing it like almost immediately, but I'll write this down over here as the limit. I'm using limit laws. H goes to 0. I want to emphasize what I'm looking at. I'm seeing this. I'll write that down initially. And then I'm seeing something else over here. Whoops, I didn't mean to put equal there. Sorry about that. I'm going to put down plus the limit as h goes to 0. And now I'm looking at, let me get a different color out. I'm looking at this one and this one. And I'm going to factor a sine x out from that. You get sine x times, I still have the h there. And you get cosine h minus 1. All right? Now, I know this limit here has nothing to do with the x, by the way. And that's just going to be 1, so I get cosine of x. The next limit, plus, is going to be sine of x, nothing to do with h. And this guy's limit over here is going to be 0. So we left off with cosine of x. All right, I want to briefly go through something with you, and I want to briefly go through this over here. All right? Most teachers at the calculus 1 level do this by the squeeze theorem. They do it geometrically. Let me just go over here, and I'll write this one down for you. Limit And I can write down theta goes to 0, cosine h minus 1 over h. And I can multiply top and bottom by the top's conjugate, which is cosine h plus 1 cosine h plus 1. What do you get here? I'm sorry, I keep using the h, and I got to erase that completely now. And right over here again. I'm going to use x this time. So limit x goes to 0, cosine x. Again, we're doing this over here. I'm just, you know, I did it again. It's all over the place. I got my numbers all mixed up. Sorry about that. So minus 1, and then I'll put an x over here. Let's multiply top and bottom by the top's conjugate. I'm really screwing up here. I'm doing a lot of problems. That's the reason I keep working. I know I record. It looks like I'm recording only one at a time. I keep moving through this, by the way. I'm on the 52nd problem already. So let's write this over here, limit. It also takes a lot of time to type this stuff up, by the way. What do you get there? You get cosine x squared minus 1, and on the bottom you get x times cosine x plus 1. Put the square brackets there. Wow, that top looks strange, doesn't it? And what's that going to be? It's actually minus sine squared. And sine squared is actually sine x times sine x. And what do you get in bottom? X times cosine x plus 1. What's this guy going to be? That's 1. What's this guy going to be? It's going to be 0. What do you get? 0, and cosine of 0 is 1. 1 plus 1 is 2. So it's going to be 0. Minus 0 is still 0. So again, these are two nice limits to know, but I'm going to say this is really kind of like the sacred cow at this point. But this one will lead to this one. Just like knowing the derivatives of sines and cosines will lead to a lot of different derivatives, by the way. Thank you for paying attention.